Okay, so the study I've just mentioned by Eagleman, going back here, this was featured in a TV programme on the BBC. It's quite a long time ago now, it must be 2008 maybe. And the programme was all about time. And as you can imagine, whenever you're working within a field and there's a programme on TV about your field, you get very annoyed. It often seems if the subject's being dumbed down, or just from a personal point of view, you're a bit miffed that you weren't asked to be on the programme. So I just so happened to be down the pub with my old PhD supervisor, John Weirden, and we were discussing this programme and this ridiculous experiment by Eagleman. And although we thought it was a bit ridiculous, we thought that there was a good idea in here somewhere about this relationship between time perception and the processing of information. So what occurred to us down the pub over a couple of drinks was this question: can we speed up the brain with click trains? We already have this very reliable behavioural technique to speed up the internal clock by using repetitive stimulation, click trains, or you can use flashing lights. So the simple question is this: if we speed up the internal clock, does this have any effect on the rate at which we process information? Are the two things linked? If I speed up your internal clock, can I make you think and act more quickly? So this is what we did. So we set up some experiments. Now this is quite interesting because my professor, John Weirden, pointed out that if we were to find this effect, then people would understandably be quite sceptical about it, and sort of thinking ahead to when we're going to try and publish this, then one of the objections reviewers might have is, they might have some objection to the type of task that you've used. So he pointed out there was no point us inventing new tasks to test information processing rate. What we should do is pick some classic tasks from experimental psychology and use those. Then whatever the results are, we won't have arguments about the methodology because these are accepted standard tests within experimental psychology. So this is exactly what we did. So we used several different tests. First was a very simple one. We used a choice reaction time. So in a choice reaction time, you have 4 boxes, and in one condition you simply respond as soon as a cross appears in any of the boxes. In the 2 choice condition, you respond on one button if it appears in one of the 2 boxes on the left, the other button if it appears in one of the 2 boxes on the right. And lastly, a 4 choice condition where you press the corresponding button depending on which of the 4 boxes the cross appears in. Then moving up, we got them to do something a bit more complicated, so we got them to do mental calculation or mental arithmetic. Again, reaction time. So what would happen here is the computer would flash up a sum together with an answer, and you had to decide as quickly as possible whether the answer was correct or incorrect. We had an easy and a difficult condition. The participants hated this task. Getting people to do speeded mental arithmetic, it stresses them out. And then lastly, we have some memory tasks, and the rationale behind these is slightly different to the reaction time ones. So in these, we're presenting information, very briefly presented, and asking people to remember this very briefly presented information. So the idea here is using clicks. If we're speeding up people's perception of, speeding up people's internal clocks, then that briefly presented stimuli should last subjectively longer. So in theory, you should be able to extract more information out of it than when you have a normal speed clock without clicks. So this is what we did. We did this battery of tests, and we used clicks versus silence, and we also had a white noise condition because we wanted to control for just having any stimulation before the thing you have to react to. Maybe that would make a difference. Maybe it's not specific to do with clicks. So we had a white noise condition as well. And in short, the experiments worked. Okay, so the clicks sped up the reaction time, they sped up mental arithmetic, they increased recall and memory encoding, and they increased recognition and memory encoding. And in follow-up work a few years later, we showed that flickers have the same effect, at least on reaction time. We repeated the reaction time task using flickers, and they also sped up the internal clock. White noise had no effect at all. So this was a pretty exciting result. A bit of self-publicity here. This actually made it into the sort of cover story of New Scientist, which for me was a big deal. As a nerdy, geeky young child, I used to go to the reading room at my local library, which used to open before the actual main library opened, and I used to read New Scientist, or attempt to read the articles in New Scientist. So yeah, the idea that geeky kid would grow up to have an article that's on the front cover of New Scientist, that was a bit of a what's the word? I don't know, a bucket list achievement. Old Luke passing a gift on to young Luke. So this was all very well, and this caused a bit of a stir. But this raises more questions than it answers. Although we've shown that using click trains, which have previously been shown to speed up the internal clock, also speed up information processing, this doesn't really answer the question of what the causal link is here. What is this link connection between internal clocks and information processing speed? We've filled in this arrow, if you like. So we've shown that repetitive stimulation speeds up information processing, and we already knew that repetitive stimulation speeded up the internal clock. But these could be completely independent effects. It might just be coincidental that repetitive stimulation affects information processing speed and it affects internal clock speed, but these two things aren't related at all. Or it could be this way round. It could be that the repetitive stimulation is speeding up the internal clock, and the internal clock, in some manner or other, speeds up the rate at which we process information. Or it could be the complete reverse. It could be that repetitive stimulation speeds up information processing speed, and this in turn increases internal clock speed. Maybe internal clock speed is just another form of information processing. And some people have suggested that actually there is no internal clock, that what we do is we measure how much information we process in any given period of time. The sensory information coming in, that is the pacemaker. We still have an accumulator, but we don't have an internal pacemaker. We're using information processing speed, or the amount of information that we've processed within a given period gives us our measurement of duration. So it could be this way around. Or as I said, it could be a completely independent effect. Or, as always within psychology, there could be some accursed hidden third factor that we don't know about. So maybe the repetitive stimulation affects arousal, it affects attention, or it reduces neural noise. These are very spurious terms that get kind of kicked around in psychology when we're not quite sure what's actually going on. But this could be the case. It could be that repetitive stimulation affects those, and those in turn affect information processing speed, internal clock speed. And it could be even more complicated than this. There could be, again, lines drawn between internal clock speed and information processing speed, like I've shown before. So what the causal relationship is here is it as yet unclear. You might think an answer to all of this would be, well, why do clicks work? If we understood why clicks and flickers produce their effect, then we might have a better understanding of what brain mechanism is going on here, what's being altered. Although the effects of these clicks are well known, why they work has been very much under researched. I've done some work on this, but hardly anyone's really investigated this. The repetitive nature of them seems to be key. So like I said before, white noise doesn't work on clock speed or information processing speed, or simply having a tone doesn't do anything. So it seems to be the repetitive nature. But in recent work, we've shown that the repetitive nature doesn't have to be strictly periodic. You can actually mess around with the speed of the clicks or the gaps between the clicks, and you still get the effect. Although how far you can go in breaking down that periodicity is still an unanswered question. Maybe at some point that there's such a lack of coherence that maybe you don't get the effect. The frequency seems to be not particularly important, so I've used different frequencies of clicks and they all cause the same effect. However, If you use very low frequencies of clicks, then you need to have a longer period of clicks. So it seems that the number of clicks matters, but not the frequency, within certain limits. Obviously, if you increase the frequency, to make it really fast, you end up with a continuous tone again, and we know that continuous tones don't have an effect. So flashes work and clicks work, but vibrotactile trains don't work. So if I attach a tactor to your finger that vibrates, I can make that vibrate in the same manner as a click train, and then give you some things to estimate the duration of. That doesn't work. I'll probably some work on that. It seems to introduce a bias, so people tend to estimate durations that follow this vibrotactile trains being longer, but it doesn't manifest itself as a slope effect. There's no effect on the internal clock. Other ideas that have been kicked around the literature about how these clicks are supposed to work. One idea is that the clicks cause arousal. This is a bit of a spurious argument. Firstly, there's no independent evidence offered for this. So if you ask people who propose this idea, why do you think click trains are arousing? Well, they say, well, click trains speed up the internal clock. Okay, it's a circular argument. How do you know the click trains are arousing? Because they speed up the internal clock. If there's an independent measure of arousal, then maybe so. So if you measure physiological arousal through galvanic skin response or pupil dilation or muscle tension, and you showed that was affected by the click trains, and that corresponded to the overestimation, then that would be good evidence. And in fact, I've done some pilot work on that, and that isn't the case. I've been unable to measure any physiological arousal caused by click trains. Some proponents might say, well, okay, it's nothing to do with physical arousal, it's actually psychological arousal. But what on earth does that mean? Is that something I can measure? I've also replaced the clicks with things which definitely are arousing. So I've used pictures and sounds which are arousing. There are libraries of sounds and pictures which have been rated for their arousing nature. Okay, so you've got photos of battle scenes or injuries or this kind of thing. And they've been rated for arousal. Or you can use sounds, so there's sounds of people screaming and being beaten up and this kind of thing. I've used those, and they don't have any effect on the internal clock, even though they definitely are arousing, and we get our participants to rate them, and they do rate them as being arousing. They have no effect on the internal clock. So this arousal argument seems quite weak to me. Other arguments that have been made is that the frequency is important, that the click frequency is somehow in phase with some internal pacemaker frequency. Now this on the surface seems like quite an attractive idea, even if you didn't know about my work that's messed around with the frequency, which makes no difference. But this depends on some quite unrealistic assumptions. Firstly, it depends on the idea that every single person who comes to take part in my experiments has the same internal clock frequency. If they didn't, then the 5 Hz or the 25 Hz that we typically use wouldn't be in phase with it. The other problem is that this is a bit of a misunderstanding about how harmonic periodicity works. So the idea is that the clicks are in phase with the internal clock, and they're somehow giving a push to this pacemaker. A little bit like if you push someone on a swing, you need to push them at the same frequency as the swing, otherwise you just get erratic behaviour. But if you know anything about harmonic motion, then when you push someone on a swing, it makes them go higher and it makes them go faster, but it doesn't change the frequency at which they pass the middle point. It doesn't make them any faster in terms of how many swings they do. And this would be the same for a pacemaker. It might strengthen the pulses or the ticks, but it wouldn't make them run faster. That's not how it works. Another idea is that these clicks cause entrainment. Now, we do know that if we subject people to repetitive stimulation, so for example, if I get you to look at a flashing light at some particular frequency, and I have you strapped into an EEG cap, I will find that the frequencies in the brain which are around the same frequency as the light that I'm flashing will increase in amplitude. you get sympathetic entrainment in the rate of the neurons firing to the repetitive stimulation that's coming in. So you might think this might be the answer, but typically in these entrainment studies, the repetitive stimulation is running in the order of minutes, or at least tens of seconds, and the repetitive stimulation is on at the same time as the EEG is being measured. And that's quite different to the clicks. With the clicks, they only last for 5 seconds, and then they're taken away, and then you get the thing presented that you have to time. So whether entrainment occurs under those circumstances, we don't know. That is something I'm intending to investigate in the near future using EEG. Another thing you might think of is, well, maybe a way out of this is to correlate internal clock speed with reaction time speed. So if I know your internal clock speed and I know your reaction time, are the two things correlated? Well, it's a nice idea, but again we're back to this state change problem. I can't measure your clock speed directly due to the state change problem. I'm not going to go through all of this again because I've been through this in other lectures and in the seminars. As you know, I've got another video on state change if you need this covering again. However, there is one possible way around this state change problem, and that's to look at difference threshold. So you may be able to infer something about clock speed. So mathematically, faster clocks should give rise to lower thresholds. By difference threshold here, I mean, if I play you 2 tones, how different in duration do they need to be before you can detect that one is longer than the other? Okay, so the better you are at the task, the lower your threshold will be. The less the difference will need to be for you to be able to detect that difference. These are the numbers. I'm not going to go through this argument. I think you can see mathematically how this all works out. If I speed up your internal clock, you should be able to detect smaller differences in duration. And in fact, I've done this work, and it doesn't work. Okay, so click trains don't reduce difference thresholds. There's actually a problem with this argument, which is that of scalar timing. So remember, we're worse at timing durations which are longer, or we're more variable at timing durations that are longer. So if I increase your clock speed, it might make you able to detect smaller differences, but at the same time, I'm making you perceive those durations as being longer. Therefore, you'll time them more variably. So you've actually got 2 opponent processes which seem to cancel each other out. At least I can't find any significant effect on thresholds by using click trains. There is some other work in the literature which kind of scouts around the same issue. So again, some work by Ramseyer, who I've mentioned before. So this work from 2007 is based around this idea of temporal G. Okay, so what they did was they got people to do 8 different timing tasks, including difference threshold that we're particularly interested in, and their performance on these 8 different timing tasks was used to calculate what Ramseyer called temporal G. Okay, so a measure of their timing performance. And what he found was that this temporal G was a better predictor of performance on intelligence tasks, i.e. psychometric G, than reaction time, Hicks's G. That previously been shown to be a predictor of performance on intelligence tasks. So this is kind of parallel evidence. It's again suggesting that there's a link between how good you are at processing time, or the processes involved in processing duration, and other cognitive faculties. But what he didn't do was look for a correlation between temporal G and reaction time, because that wasn't the thing that he was interested in. So this experiment gets close, but it doesn't quite answer the question that we were interested in. But again, it is all kind of suggestive evidence or circumstantial evidence that's pointing in the same direction.